I just kicked something.
Like this.
All right, hello people watching this video. This is Tutu. Notes for Calc. One thing that I'm going to preface this with is that on your homework assignment, number 3 has a typo. This should be to the third power. No, wrong. Number 4. Number 4 should be to the third power. Wrong. 4, switch him. He should be 2x to the third power instead of x to the second power. Otherwise, you're going to run out of graphs that are correct.
What's to the third look
So,
like?
to the third,
Yeah.
I don't know, is like a little one of these guys or something.
What does it mean when you have an
Or
X in the
something.
second spot?
So this one maybe.
Okay, good? Happy with that? Okay, let's go to the notes. Go to the notes. Go to the notes, and I'll go fast. Here we go. I don't know. Maybe we'll see. We'll see how fast we go. It doesn't take very long, though. Okay, we're going to get through this first page in like a lickety-split. All right. Polynomial functions. Quit it. Polynomial functions is, they are linear
Did you do
functions.
it so they can hear you?
Yes, I did.
You
Polynomial
sure?
functions, linear functions, quadratic functions, so like x's, x squareds, x cubed, which are cubic functions, x to the 4th power, x to the 5th power, etc. All of those are polynomial functions. What are not polynomials are like square root of x, or absolute value of x, or 1 over x, or any of those. These are not polynomial functions.
So just
no.
x's.
Okay? So just x's and x squareds and x cubes and all that good stuff, okay? Polynomial functions are continuous, meaning they have no breaks and are smooth and rounded, okay? So here is an example of a polynomial function. This is more specifically an x to the 3rd power, probably. This one has a break in it, is not continuous. Not continuous, so this is not a polynomial function, okay? This one is a polynomial function. He is rounded. What do you think he is?
X to the 1, 2, 3, 4, 5th.
5th. X to the 5th. He goes in opposite direction, so he's got to be a 5 or an odd number.
This
And
is
the fact that he has a bunch of bubbles.
absolute value.
This one's absolute value, but is he a polynomial?
No.
No, because he is not rounded. Not rounded. He comes to a, like, tippity tip at the bottom. Not rounded. Okay, so polynomial functions. A polynomial function is even if it is, well, you tell me. Even. What was even symmetry?
Respect to
To the
y.
y-axis symmetry. Yep. Y-axis symmetry. Do you remember how you tested for y-axis symmetry?
Negative x positive y.
Yep. Negative x, positive y. Okay. Odd is
Hudson!
Origin.
odd is origin symmetry.
He's being a little...
Both.
Origin symmetry, and it's negative x, negative y. So
Yeah,
you
I can
plug a
tell.
negative in for both of them. That's odd
one place to
functions.
go.
Okay. So
I want to do.
they say that examples of even functions are like x squared or x to the 4th power or x to the 6th power. Odd functions are x to the 3rd power. Now, I am here to tell you that not every single x to the 3rd power function is odd. For example, if you have x to the 3rd plus 3x squared minus 1, this is not going to be an odd function anymore. Does that make sense? Because of these things, it makes him have extra bubbles in him, okay? And it's not going to be origin symmetry, right? Okay, same thing with an x squared. Not every x squared function is a even function. Like x minus 3 squared. Let's just think or talk about what that looks like. How does that 3 move an x minus, like, how does that move that parabola?
Right 3.
Right 3. 1, 2, 3 to the right. Okay, now is he symmetric with respect to the y-axis? Not anymore. So even though he is a quadratic function, he is not an even function. It's only an even function if it's just x squared, etc.
Where are
Right?
we even at?
Okay, we're talking about even and odd, right?
Where?
There. Okay. All right, transformations of functions. Sketch the graph of each function. X to the 5th power, if that's the parent function, what's the minus do to it?
Flip it down.
It flips it down
I'm-
over
Give me
x,
my back.
over the
Yeah,
x-axis,
like
okay? X to the 4th power looks like a flat tire. What's the 1 do to it?
Left one.
Moves it to the left 1, okay? That is going to come in handy, like knowing those transformations when you go to do the matching part on the homework assignment. Good? Capiche? Okay,
suppose, but
all
this
right.
Doesn't really make sense. It seems like what we've been doing.
Yeah, it does seem like what we've been doing. Exactly.
But
I don't.
Yeah.
I'm
Okay,
just-
moving on. if a function is odd, okay, like it has an odd exponent, okay, they're going to go opposite directions. Its end behavior is going to go opposite directions.
Where is that at?
Okay, like here or here or here or here. Odd functions like x to the third power, if it's x to the third or x to the fifth or x to the seventh, right? Any of those, they're going to go opposite directions, okay? If it is a positive, if it's positive and odd, it is going to look like this graph. Positive and odd, it's going to go uphill from left to right. If it is negative and odd, it's going to go downhill from left to right. Make sense?
No.
Okay. If it's like negative and odd would be like negative x to the third power,
It's just like a
right?
line.
Negative x to the third power is going to start on the left and end on the right. Down, up on the left, down on the right, right? Positive and odd. Yes, maybe? Negative and odd. Positive and odd, negative and odd. So like this would be like just x to the third power, and the other one might be a negative x to the third power. Okay? Good? It's an even function, like x squared or x to the fourth power. Let me write this in here. There we go, upside down. If it's x squared or x to the fourth power or x to the sixth power, or any even parent function, the end behavior is going to go the same direction, right? Like x squared is a parabola, up and up. Or down and down, okay? It's down and down if it's going to be negative. So if it's negative and even, it's going to go down and down. If it's positive and even, it's going to go up and up. Does that make sense? Positive, even, negative, even. Right? Like, that's how you know. How you know. Good? Okay, quit. We have examples, 1, 2, and 3 off to the right-hand side, and it says
Negative,
describe the right and left-hand behavior. There is a way of doing that, and you have to be specific. You have to write out the notation that we use.
What?
We say, as x goes to infinity, the y is doing something. And then we fill in the blank. As x goes to negative
I
infinity,
hate
the y is doing something. We fill that in every single
I
time.
liked this.
Yeah, it's not too bad. X goes to infinity. The y is going to something. As x goes to negative
You
infinity,
should have to graph
the
it.
y is going to something. We are going to do a little rough sketch of what it looks like, because otherwise we can't do it then. Behavior. As x goes to negative infinity, the y is doing something. We're going to fill that in for each one of those. That is how you describe they call it end behavior. End behavior. Or the left and right hand behavior. Left and right hand behavior, or the end behavior. My algebra kids just got done doing this, and they actually do it very well. I'm very surprised. They grasped it right away. Okay, parent function here on the first one, on number 1, is x to the third power. And it's negative, so he's going to do something like this, right? He's going to go downhill from left to right because it's negative, and he's odd, so he goes opposite directions. So as x goes toward infinity, this is a fancy way of saying as the x's go toward the
Negative infinity.
right. On the right side of the graph, he is going down, correct? So negative infinity. This guy is like saying he is going to the left. As x goes toward negative infinity on the left side, he is going up. So we put infinity.
What's this graph?
Make sense? Something like that. I don't know. Something like that. You might have more bubbles in him, whatever. Okay? X to the fourth power. It's positive x to the fourth power. What's he going to look like?
Up and up.
A W, up and up, right? So on the left side, on the right side, doesn't matter. He's going to be positive infinity no matter what. Good? Does that make sense?
So this one
Okay.
is this.
This one is x to the fifth power, and it's positive. So he's going uphill. So he's got like a bunch of bubbles, and he's going uphill from left to right. So on the right side, he is going
Down.
Up, up.
up.
What?
Right side, he's going up. Left side, he's going
Down.
down. So negative infinity.
Wait, what was the?
It's like
This one
Infinity,
is x to the fourth power. He's a W, so he's up and up.
like
Infinity, infinity. Yep. Good. Happy with that? That's what they call that the leading coefficient test. So it tells you whether it's positive or negative, that type of thing. Okay. Moving on.
This.
Moving on. Moving on. Okay.
You did it in one swipe though.
Zeros. What's a zero of a function? Shh. What's a zero of a function?
The
X
root.
is-
The root, or the x-intercepts, the zero, or the solution, or the factor, or the x-intercepts, or the roots. Okay, those all mean where he crosses, where the x
You just
intercepts
said it.
are.
I
Okay.
said that's cool, not you.
All right, so any of those things, when it says find all real zeros, it means find where he crosses, okay? How do I find where he crosses? How do I find the x-intercepts?
You
Set them equal to 0.
Put 0 in for y or set it equal to 0, okay? So what can I do to this to solve it?
And pull X's and 2's out.
Solve it.
Yeah, I can pull x's and 2's out, right? Okay, well, what would you like to pull out?
2x squared.
2x squared, sure, okay. Left
Or-
over, do you want to pull a negative with it or not?
Yes.
Yes?
No.
Okay, pull a negative with it, okay? And if we do that, then what will be left?
Negative
squared
1
plus-
plus
X squared
Negative 1.
nothing.
minus 1.
Oh, that's
Right?
right.
Plus
Yeah?
negative
X squared minus 1.
plus
Now, this guy technically is something special.
He's
What'd she say?
difference
He
of
is a
squares.
difference of squares.
Why is this a thing?
Square root, difference of squares. So this guy will break down into
X plus 1, X minus
x plus 1, x minus 1, and we still have our minus 2x squared. Now that I've broken him down, what do I do?
X equals plus minus 1.
Yeah, I set each piece equal to 0. So negative 2x squared equals 0. Like x plus 1 equals 0 and x minus 1 equals 0. If I do the negative 2x squared equals 0, divide by negative 2, right? X squared equals 0 divided by negative 2 is 0. And the square root of 0 is still 0. Now, this 0 is special because he
minus.
has plus minus, which means this 0 has a multiplicity of 2. Okay, multiplicity of 2. That means 0 shows up as an answer twice. We're going to talk about that here in a second. Okay, 0 shows up as an answer twice because it was x squared equals 0. So it's technically plus and minus 0. Therefore, we have 2 answers that are zeros, right?
So he probably goes
Okay.
like up and then gets to 0 and then up again.
Yes.
And
Yes.
OMG.
Yes. All right. Now, if I set this x plus 1 equal to 0, x equals negative 1. If I set this equal to 0, x equals positive 1. Okay. I got 3 answers, 3 zeros. How many should I have gotten?
then 4.
4, because he's x to the 4th power. Why did I only get 3?
Because there's a multiplicity of 2.
Because 0 has a multiplicity of 2. So that's like 2 answers in 1, right? So that's what, I don't know if you can see this very well, but that's what Sarah just said, where she said it's probably going to go up through 1, through negative 1. It's going to come down. It's only going to touch 0. It's not going to go through it. And then it's going to come back up and touch 1 again. So there's all 3 of them. So if it has a multiplicity of 2, FYI, it's only going to touch. It's not going to cross at that point, right? 0 had a multiplicity of 2. That means it just goes and kisses that line, and it doesn't go through the line, right?
What's the difference?
What?
What's the difference?
If it has a multiplicity of 2, it's just going to touch. It's not going to like go through at that point. Like this point right here had a multiplicity of 1 because it only showed us up as an answer once. So that means it's going to cross the x-axis at that place, right?
Why does
Here
do
it
that?
crosses the x-axis. It just can tell you like more about what the graph looks like, right? To help you graph it. Okay, so if you have a multiplicity of 2, it's just going to go down and touch and then go back up. Okay, all right, that's what the repeated zeros says right here. Multiplicity. If it has a odd multiplicity, like it only shows up and it's an answer once, it's going to cross. If it has an even multiplicity, like it has 2, it's going to go and touch, but it's not going to cross. Does that make sense? That's what this box said. Yeah, very good. Okay, next.
Is we done?
Blah, 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 blah,
Yeah, can we
blah,
be
blah,
done?
blah, 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 blah,
So much
blah.
I'm struggling to pay attention.
You weren't paying attention to begin with.
Yes,
All
I
right,
was.
we can be done, and we can save these last 2 examples for Monday if you go through and do
The matching.
the first page,
Oh, you don't know how
1
to
through 11.
I'll do the
Go,
matching.
So what
go
do
do
these
1
mean?
through 11.
This is not your homework.
Could be.
Okay, goodbye.